Now let's talk about how to graph tangent and cotangent functions. So in a tangent function, we can see that the period to repeat a cycle is different from what we had seen with our other four trig functions. It only takes 1 pi to complete a cycle, which we had seen in a previous video. Moreover, you'll notice that the range of a tangent function is from negative infinity to positive infinity. So as we look at our tangent function, it will be beneficial to remember these 5 key points, or maybe not 5 key points, but the 5 key x values. I say that they're not 5 key points because the first value and the last value of our table do not yield points, but vertical asymptotes. So let's proceed as before in all our graphing. Let's identify the period. You'll notice that there's a horizontal compression here, so that will affect the period. Now, in this case, the period, which is always identified by t, but in a tangent function, the original period of the parent function is pi, not 2 pi as in sine, cosine, secant, and cosecant functions. So we have pi, and that is being compressed by a factor of 2. So our period is pi over 2. That means that our increment is going to be pi over 2 divided by 4. So pi eighths. So let's go ahead and look at our original parent function's values. And let's see how that changes for our new function. For this transformed function, the outputs are not changing, it's the inputs that change. So maybe to best see what's happening, let's look at x equals 0. If we compress that by a factor of 2, it will not change. But then we can go out from that our increment of pi eighths. So 0, pi eighths, and then 2 pi eighths. And we can go to the left also. So negative pi eighths and negative pi eighths. I'm sorry, negative 2 pi eighths, which is the same thing as negative pi over 4. So the y values do not change. This will yield an undefined value. This will be negative 1, 0, 1, and this will be undefined. So now let's look at our x-axis and tick off the x-axis using our values from the table. So negative pi over 4, negative pi over 8, and then we can count using our increment. So that was negative pi over 8, 0 pi over 8, 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, 5 pi over 8, and 6 pi over 8. Now we find our y-axis, which corresponds to x equals 0. Put our y values of 1 and negative 1 on our axis. And now we know that for negative pi over 4, according to our table, that corresponds to a vertical asymptote, as does pi over 4. And then plotting our key values, notice that tangent increases on the interval as long as there is no vertical reflection about the x-axis. And then we repeat that same pattern. So -1, 0, 1, followed by our vertical asymptote. Now, to find the domain of this function, we need to find the x values that correspond to our vertical asymptotes. So we could choose any one of the x values, say -π/4 or π/4 or even 3π/4. We say x does not equal that. So x does not equal π/4. And then how long is it until our next vertical asymptote? And you'll notice that the distance between vertical asymptotes is π/2, which would not coincidentally is the same as our period. So π/2k. The range is -∞ to infinity. In this next example, we have several things going on. So let's rewrite our function so that we can see our transformations of our input more clearly. So y equals negative tangent of 4 times, and then I factor out that 4 from within the argument. I can't pull it outside of the tangent function. It must stay within the argument. So what do we see here? We see 3 transformations. We see a reflection about the x-axis, we see a horizontal compression, and we see a shift to the left of π/4 units. So what's this mean? The period t is equal to the original period of the parent function divided by 4, because we have been horizontally compressed. That means that our increment is that period, π/4, divided by 4, so we get π/16. And keep in mind that this has all been shifted left π/4 units. So let's look at the original parent function's values, and then this function's values. So from our parent function, we have this table. Now let's see how things change for our new table. So I'm going to start off with the easy value of x equals 0. So with x equals 0, where does that get changed to? With x equals 0, we have been compressed horizontally by a factor of 4, but that does not change anything for 0. 0 compressed is still 0. But then 0 shifted to the left π/4 units is now -π/4. Now the easy thing to do, rather than looking at each of these 4 other values, is to instead just use my increment of π/16. So we will move to the right by π/16. So it helps to think of this with the denominator of 16. This is the same thing as -4 π/16. So if I add -4 π/16, if I add π/16 to that, I get -3 π/16. Then I add π/16 again, that will be -2 π/16. And then I can go to the left, and I have -4 π/16, so -5 π/16, and -6 π/16 is -3 π/8. Now, -π/4 is mapped to 0, and then reflected, nothing changes. -3 π/16 was mapped to 1 and then reflected, and then -π/8 should correspond to our vertical asymptote. -5 π/16 should be mapped to 1 because of the reflection, and then our vertical asymptote corresponds to negative 3 pi over 8. So now let's go ahead and look at our x-axis. So we start off with the leftmost value in our table is negative 3 pi over 8. It will be beneficial, again, to think of that as a denominator of 16. So instead of negative 3 pi over 8, think negative 6 pi over 16. Negative 5 pi over 16, again, we're just using our increment. Negative 4 pi over 16. Negative 3 pi over 16. Negative 2 pi over 16. Negative 1 pi over 16, 0 pi over 16, 1 pi over 16, 2 pi over 16. Then we find our y-axis by looking at where x equals 0 and putting our values of 1 and negative 1 on our y-axis. And negative 3 pi over 8 corresponded to a vertical asymptote. As did negative pi over 8. Negative pi over 4 was mapped to 0. Negative 5 pi over 16 corresponded to 1. Negative 3 pi over 16 corresponded to negative 1, and we can go ahead and draw that first cycle. And then we repeat the pattern. One thing to watch out for whenever you graph tangent functions, and as we'll see in the next examples, the cotangent function, is they almost look like cubic functions, but the cubic function levels off right here. And so this does not level off. So instead of feeling flattened, it feels still sloped. Now let's look at the domain of this function. The domain is the set of all x values, and then we find a vertical asymptote. It doesn't matter which one. So I'll choose pi over 8, and then from there I know that I can choose to look at the next, or the distance between vertical asymptotes, as being pi over 4, which is the same thing as the period. So our domain is all x values where x is not equal to, a little squish there, so let me erase. X does not equal pi over 8 plus pi over 4k. The range is negative infinity to infinity. So now as we move to our cotangent function, it looks very similar to our tangent function. Our vertical asymptotes this time have shifted and our function decreases on the interval. But you'll notice that our period for this function is still pi units. So as we look at our key values, we start at 0 and we go to pi with an increment of pi over 4 because that period is pi, and so we divide it by 4 to find the increment. And we can see our vertical asymptote and another vertical asymptote, and these happen every pi units. So let's go ahead and look at a graph of a cotangent function. As we look at the graph of this cotangent function, you'll notice that the period is still pi units because there is no horizontal transformation. What we do see is a vertical stretch. So if we look at our table for our cotangent function that we start with in our parent function, that is, we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. And then we have undefined for the y values to begin with and end with. In the middle we have 0. And then remember that our function decreases on the period unless there has been a reflection, which we do not have. We do not have a vertical reflection, a reflection about our x-axis. So let's look at our transformed function. The inputs do not change here because there's been no horizontal transformation. But we do see that our y values that are defined have been scaled by a factor of 2. So let's go ahead and look at the graph of this. Looking first at our tick marks. So we're looking at a period of pi, so our increment is 1/4 of that. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4 is just pi, 5 pi over 4, 6 pi over 4 reduces, 7 pi over 4, 8 pi over 4 reduces to 2 pi. Finding our x equals 0 corresponds to our y-axis. So let's put our 1, actually not 1, we want to put 2 and -2 on our y-axis. And we know that x equals 0 corresponds to a vertical asymptote, as does pi. Then we can go ahead and graph. Cotangent functions decrease on the interval. Unless there has been a vertical change, a reflection about our x-axis. And then we repeat the pattern. Now we find the domain. And the range. The domain is the set of all x's where x does not equal, and we pick a starting point, a starting x value that x can't be. And so in this case it would be 0. It'd be fine to use pi or 2 pi, but if we start at 0, then we can add to that every 2 pi units. So 0 plus 2 pi plus 2 more pi, so on and so forth. And we know that x then cannot be any 2 pi k value where k is an integer. Our range of this function is -∞ to infinity.